Hello everyone, welcome back. In the last section, we have seen how we can create a sentence paraphraser or even a text paraphraser, splitting sentences and parallelly processing them. So essentially, once you have some working code in the Collab notebook, how do you make an API from it? And what exactly is an API and what is ML model deployment? That's what we are going to see in this section. So in order to understand deployment, let's understand what happens once you have some working code. So for example, let's say you have some working code. In our case, we built Paraphraser, and this is one of my production app, question.ai, where I've built a question generation algorithm to take in any text and generate some question and answers. So first let's run this. For example, I'm choosing FAQ and just clicking on generate questions. I'm demonstrating it so that you understand what exactly is API and why do we need to do ML deployment, etc. So as you can see, I've sent in some text and it returned me a question with corresponding answer. A question and a corresponding answer. So you can assume this is kind of built on GPT-3, just like how we have built Paraphraser. Now the important thing is that once you have some code tested out in Colab or Jupyter Notebook, we want to convert it into an API, application programming interface. What that means is that any production apps, etc., can have some front end that calls API with the input, in our case text, and whatever is the output, that is in this case question and answers, is kind of returned in a JSON format. So you take the code in your Collab notebook, then you create a input output transaction format. Essentially input is text, raw text, then probably you are returning paraphrase text, that's the output, and you need to create a way on the web for any client to send in some text input and get back this paraphrase text as output in the form of JSON, etc. So doing that exactly is basically deploying ML API. So making your service available for anyone on the internet to use or for your particular client to use, that exactly is ML deployment. And what are the constraints that are involved here? First of all, there might be 100 or 1,000 simultaneous users who might be using this, and we want to show them the output without any delay or lost messages. So there are two different things that you need to understand: auto scaling and load balancing. Auto scaling means, for example, you just have one API and probably you can send in text and get some response back as JSON. But if there are 100 simultaneous users who are calling that API, will you be able to handle the load? That's where auto scaling comes in picture, where you need to be able to scale or have at least resources to be able to handle that kind of load. So that's what is auto scaling, to support many concurrent users. And the other thing is load balancing. Let's say there are 10 different machines that are ready to take in any text and return the paraphrase JSON. But let's say if you have 1,000 incoming requests, how do you evenly distribute the load and send to these 10 machines that you have? So that's where load balancer comes into picture. Most of the times the auto scaling and load balancing is taken by the infrastructure that you use. So in short, converting your Collab notebook code into an API so that everyone can use on the internet is basically ML model deployment. And deployment doesn't mean just providing an API, but you need to make sure that that API is scalable, so auto scaling, as well as load balancing is enabled. And like I mentioned, mostly if you use any of the cloud services like Amazon Web Services, AWS, or Google Cloud, or Microsoft Azure, all of them have built infrastructure to do load balancing and auto scaling, etc. Now again, in order to create APIs, you need to make use of some libraries like Fast API and Flask. Fast API is more advanced version that is popular in the recent times. So most of the people use Fast API to create an API from scratch. And what exactly is containerization and Docker? Simply put, if you have a model of 1 GB size, then you need to package the model, then put any libraries like Spacy, PyTorch, all these models on top of that. Then you need to have inference code which will take in some text and do the processing with the model and return back the output text in a JSON format, etc. So all that needs to be packaged somewhere, and that's where this containerization and Docker comes into play. Basically putting all the code, the model, and any other libraries and dependencies, packaging them and putting them into a container is called as containerization. By container, I mean it's a fully packaged virtual machine and you can deploy that anywhere. So Docker is the tool that will help you to do that containerization. And why do we do this? Because oftentimes we encounter this problem where people say that it runs on my machine. People say that I've run it and it runs on my machine, but I don't know what's the problem, why you are unable to run it on your machine. So if your deployment is not packaged with everything included, even the operating system, then you might encounter a lot of failures because of system dependencies or the platform being different, etc. So in order to streamline that process and make sure that everything that needs to be run is packaged along with the operating system, the concept of containerization came into place with tools like Docker, etc. So whatever code you have, you can package that into a Docker container, and you can make sure that no matter which operating system you have, etc., you can run that container as it is and all the dependencies, etc., are taken care of. That's what containerization is. And what we are going to do in our case is we are going to use AWS, Amazon Web Services, and use AWS Lambda to be able to deploy these APIs. So first we'll start with a sentence paraphraser where we can combine OpenAI's GPT-3 and build a sentence paraphraser. Now we'll add more bells and whistles to it, which is using Spacy to split any long text. So we'll move from sentence paraphraser to text paraphraser, like we have seen with concurrent futures where we are using multi-threading and Spacy and paraphrasing text as a whole and returning back. Then we'll also see an example of sentence transformers, take in any text and how you can return back a vector. And for the most part, what happens is that AWS, Amazon Web Services, takes care of providing the base layer for containerization, etc., so that we can just use that base layer and deploy that. You'll understand it once you get there. Now there are two other different concepts that you need to be aware of: serverless and the non-serverless part. So if you deploy an API and you need to make sure that that API is available 24/7 and 365 days, basically you need to pay for the full compute of that machine. But if you have any way to cut down that cost and only bring up the machine only when you need it, that is only when someone calls your API, that is called as serverless compute. So AWS Lambda is one such, where you can use serverless functions which will only get up and running when there is an API request or some event, and they'll do the processing for those couple of seconds and go back. So you only get billed for the compute that you use. So if you use it for 10 minutes in the whole month, you only get billed for 10 minutes of compute. So essentially, if you can do something serverlessly, you should do it that way to reduce the costs, etc. But sometimes there are latencies as well. If you have a long model that takes a lot of time to boot up, then probably serverless might not be the way to go as well. There are trade-offs to it, but that's on a high level. Now, like I mentioned, what you can do is you can create these containers, and you can scale those containers up and down. So auto scaling and load balancing. And a lot of platforms, AWS, Google Cloud, Microsoft Azure, all of them provide tools for scaling the containers and load balancing the containers. The concept is called as container orchestration. And Kubernetes, and on AWS you have ECS, Elastic Container Service, and EKS, Elastic Kubernetes Service. All these are container orchestration platform where you can deploy your containers that have API and scale them up and down. And there are quite a lot of companies, startups that kind of offload this process. So companies like NLP Cloud.io or Slay.io, SLAI.io, and Banana.dev. All these are like GPU or CPU serverless platforms that take care of MLOps. So you don't need to create the containers and other things. You can just bring in your code and they will deploy it scalably, doing load balancing and auto scaling on their end. So there are many new age auto MLOps platforms as well that came into existence. If you want, you can build this API and auto scaling things on your own using AWS, Google Cloud, or any of the available cloud systems, or you can delegate that process to dedicated MLOps companies like Banana.dev, Slay.io, NLPcloud.io, who are specialized in deploying these APIs and scaling. So that's about ML deployment in short, and we will see in the next section how we can use AWS to start deploying APIs for our use cases.